the Earth to the Moon. Now, we have here a diagram which has just been started out to indicate the rate of progress of a signal sent by radio from the Earth into space. So here's the orbit of the Earth. We will see how long it takes for that signal to get to the orbits of the other planets: Venus, Mercury, the two interior planets, Mars, the next planet out. Here's the Sun, and Jupiter and Saturn will be out here. And so in the next few minutes, we will follow the progress of a radio signal. And this is the fastest that anything can travel. So what we are going to see is the fastest travel time that is possible. Now, what I would like to do now is to, while we're waiting for the light to get to other planets, to begin a discussion of a particular planet. We would like to study in some depth a strange and exotic world. Let us imagine that we know nothing about this world, that we have no prior information about it, and we approach it with absolutely open minds. We have no prejudices about whether it's inhabited or not, whether there are volcanoes or rivers, or if there are inhabitants, what they look like. Maybe they are all squamous, blue ovoids with 30 tentacles and float 1 meter above the ground. Or perhaps that's what we look like. Perhaps we're from some other planet, let us say. And we will examine this distant and exotic world, which by accident is the Earth. And first, we will look at it from telescopes from our world, and it will be little, and we will not see much detail. And then we will come closer and closer and look with... we just heard another hello universe, because our radio signal has just gotten to Venus. And we will shortly be interrupted by another hello universe when it gets to Mars. It's just reminding us of the progress of our radio message. We will look mostly with photographs, first from our planet, as I said. Then we will put cameras on imaginary spacecraft which will fly by the Earth, then go into orbit about the Earth, and then land on the Earth and look around and see whatever is to be seen. Now, in addition to looking, we can use scientific instruments to determine other factors about a planet. For example, we could pass the sunlight reflected off the planet through a device called a spectroscope, which divides the light up into individual colors or wavelengths. And if there are colors or wavelengths missing, subtracted by the passage of sunlight through the planetary atmosphere, we can, by appropriate laboratory comparisons, determine something of the chemical composition of the atmosphere of the Earth. And we would find that it was composed of nitrogen and a rare and poisonous gas called oxygen, some carbon dioxide, some nitrogen, small amounts of water vapor, ozone, some other gases. All of that could be determined remotely without ever going there. Hello. It has just reached Mars. Another thing we could do, we know how far the Earth is from the Sun. We know how much sunlight is absorbed by the Earth. We could calculate how hot the Earth ought to be from the sunlight which reaches it. We could test that idea by putting a heat-sensitive device, a thermocouple, say, at the focus of a large telescope, and see how much infrared or heat radiation the Earth gives off to space. And in that way, we could begin to get some idea of the physics and chemistry of the Earth's environment. Well, I'm going to now begin this exercise, and I would ask you, oh yes, Mercury, it's just reached Mercury, yes. And I would ask you to pretend that you do not come from the Earth. You are from somewhere else. You don't know about the Earth. You wish to find out. Well, here's our first view. It's not very much. Hard to tell much about the strange planet Earth from this view, we see a half Earth. We already know it goes through phases. We see white with some patches. It is, in fact, the clouds of the Earth that we see. The Earth is, on the average, about half cloud covered. We obviously have to have much better observations in order to determine more about the Earth. Occasionally, we find the Earth in a strange locale, in this case, just passing in front of the sun. It makes for a very beautiful picture, does not tell us much about the Earth. The Earth is the completely dark thing in the foreground, which is almost obscuring the sun. As we get closer to the Earth, we can observe more detail. Here you can see the wispy, lovely cloud patterns, and you can see that on the average they do cover about half the Earth. We can see down at the bottom the Antarctic ice cap. We can see a continent underneath the clouds. That is, the clouds come and go, but underneath them are features which don't seem to come and go. The continents are the same every time they appear over the surface of the rotating Earth. And there are also dark regions near the continents, which eventually we would discover were oceans. And that would be very strange, because nowhere else in the solar system, at least today, are there oceans. And if we looked in the extreme upper right-hand portion of this picture, we would see the Horn of Africa, the Arabian Peninsula, the Sinai Peninsula. There would be no sign, for example, of tank battles in this region. And the reason for that is that our resolution, our ability to see fine detail, is only about 100 kilometers. In this picture, we could not see anything smaller than 100 kilometers across. And therefore, if we were to see a tank, it would have to be 100 kilometers long. And that is a very large tank, which, fortunately, does not exist on the Earth. So to examine more closely, we must get better pictures. And here we see a close-up of the same region. This is the region of the Nile Valley and the Ismaila Canal. You can see this beautiful cloud which runs from lower left to upper right. It is a jet stream cloud. You can see lots of wispy clouds. At this point, our meteorologists, our experts in weather, would start getting very interested. Our geologists, our experts on the surface features of the planet, would get very interested. Our biologists would be dreadfully bored. They would not see anything of interest, no hint of the Earth being inhabited, although they might argue that liquid water was good for life. There would be others who would dispute that. Here is a lovely picture of a cyclone, which would make our meteorologists extremely happy. They would study this picture for a long time. Here, well, there's a strange object in the foreground, which I ask you to ignore. That, of course, would indicate the presence of life. This is a Skylab spacecraft. But again, underneath it, all sorts of little wispy clouds. Here is another incidental spacecraft in the foreground. This is Gemini. Again, by the way, look at the edge or limb of the Earth. You can see this little blue band following the horizon, and that is the atmosphere of the Earth seen edge on. The tall stick with a cylinder on top of it is the means by which astronauts communicate to the ground. I sometimes like to think that it's an old tomato soup can connected to Houston, Texas by a long string that you can see a little of. The other end of the string is another can, and they talk to each other that way. The trouble is that the string gets wound around the Earth many times, and it becomes a little awkward. That's not actually the way the communication is done. It's done by radio. That's the radio antenna. It just looks like an old can in a string. That's all a parenthesis I couldn't resist. Let's go back to our extraterrestrial guys. Here is a lovely volcano. We are looking at the volcanic caldera, the hole in the top of the volcano. You see this dark thing right there.